This video is to help anybody in the Circuits 2 section with the Lab 3 experiment. We're doing the maximum power transfer theorem in AC circuits, and it's kind of a continuation of the Thevenin experiment that we did last week. So we have some starting experimental circuit. We transform it through the Thevenin, finding the Thevenin equivalent impedance and voltage, and then we'll use the complex conjugate load here to determine when the maximum power transfer happens at this component. And in fact, I'll turn to Multisim here. This is my starting circuit here. I can determine the impedance across these two nodes. I can use the impedance meter in Multisim, or I can go to I can use this little calculator that Hyperphysics provides. Just punch in my values. It tells me what resistor value to use and what reactance I'll need. So I add those components in, right, based on my reactance and based on the resistance that I needed, and I change my voltage values, change the phase, and then here it's the complex conjugate. This real value is the same in both cases, but this is the negative value. This is the inverse value of what I got for this inductor. And so basically we recreate that circuit here, but my values, my capacitor values and inductor values are a little off, so there's some discrepancy in my maximum power, where my maximum power transfer occurs. So when I do this experiment, actually I'll continue here in Multisim, and I do a parameter sweep, run this here, my maximum power transfer occurs somewhere around the 22 ohms as expected. And basically what I want to do is just take a series of resistance measurements, right? Start on the low side. So the same way the parameter sweep here is plotting the resistance values from below my maximum up to some value. Now you probably don't need 300. You just kind of want to see that the peak rises and falls back down. And it's doing so according to this equation here. It's 1/2 I squared RL. So as you modify this RL value, this is a nonlinear equation, so you see a rise and fall. And that's what we get here. Hopefully when we plot this, as we change the resistance value of our load, we go from low to high, we should see something similar. That even though it permits a lot of current at this very low value, the power is still very low because that resistance value is very low. So it rises up to some point. Now again, I have a discrepancy here as I did my measurements, so it doesn't correspond to 22, but you should at least be able to see the rise and fall of your power transfer. So turning to the physical circuit, here I have my resistor. I have a separation between my resistor and my inductor, so I can quickly switch between doing current measurements and resistance measurements. So let me move this in the way here so we can actually see. So I take a small screwdriver, and what I'll do, I'll switch to a current or a resistance measurement. I make a resistance measurement here. I have some value, 124 ohms, right? I can modify this on my potentiometer by turning the set screw. And I keep my circuit on because since these are separated, the function generator won't affect my resistance measurement. So then I can modify that resistance measurement. Let me increase this up to 152.6 ohms. I'll punch that into my Excel spreadsheet. And I already have the formulas all worked out so that I just have to punch in the values and it calculates the power at that resistance. And then I switch my inputs here, go to a current measurement, and this is giving me the RMS current. Punch that into Excel as well. And then I see that gradual reduction, right? So I'm switching between a current measurement and a resistance measurement for this R load. I'm using a potentiometer for that, makes it a little easier. And then I want to be able to graph this, but you can just see from the values that this is increasing up to some maximum and then going back down. And that's basically what you want to do for your experiment. So it's fairly simple. It's a continuation of the Thevenin equivalent circuit. And if you have any questions, we can talk about it in the lab. So thanks for watching.